So a piece of pipe was to be electroplated with copper. The electrolyte is copper 2 nitrate and the cell runs with an efficiency of 89%. The current required to deposit 5.66 grams of copper in 12 minutes is. So this is straightforward Faraday's, except we've also got to think about that percentage. Now I have picked this question for a very particular reason, and that is to make sure that you know how to apply this percentage properly. Probably thinking, well, of course we know how to use percentages, but you'll see what I mean. Okay, so we're trying to find the current required to deposit that amount of copper. Right. So I know the mass of the copper. If I know the mass of the copper, what can I find? I can find the mole of the copper. If I can find the mole of the copper, what else can I find? I can find the mole of electrons, because I can use the half equation and the ratio to find the mole of electrons. If I know the mole of electrons, what else can I find? Charge. If I know Q and I've got T, what can I find? I. Right, so that little sequence is very typical in Faraday's questions. Or the other thing that's really typical is just doing it in reverse. I'm going to do this question as if it was 100% efficient, and then at the end I'm going to take into account the 89% efficiency factor. Okay, so we're just going to do those steps. So we'll take the mass, we'll find the mole of the copper, is the mass divided by the molar mass. Now we're electroplating with copper, which means we're going to have copper ions being reduced to copper. So if I know the mole of the copper, I can find the mole of electrons. So mole of electrons is 2 times the mole of the copper. Okay, once I've got mole of electrons, I can find Q. So Q equals the mole of electrons times the charge on 1 mole of electrons, 17203 coulombs. Then Q equals I times T. So I equals Q divided by T. 17203 divided by the time. The time has to be in seconds. Gives me 23.89 amps. Okay, and then we have to take into account the 89% efficiency. And some students will just go, okay, well I'll find 89% of 23.89 amps. Does that make sense though? That's right. Okay, so the way I get students to think about this is we're required to get 5.66 grams of copper. That's how much we want to get. If it runs at 100% efficiency, then this is the amount of amps that I'll need. But it's not running at 100% efficiency, it's less efficient than that. So am I going to need more amps to get my 5.66 grams of copper or less amps? I'm going to need more amps. So it doesn't make sense to find 89% of that number because that will give me less amps. Okay, so you have to think carefully. I already know what my end product is. I need the 5.66 grams of copper. But because it's less than 100% efficient, I'm going to need more than that amount of amps. The question you're trying to solve is actually this. 89% of what amount of amps will give me the 23.89 amps I need to get the 5.66 grams of copper. Happy? Right, so then when you rearrange it, you get 23.89 times 100 divided by 89. And then you'll get 26.85 amps. So we had to use the percentage in this funny way because we knew how much of the end product we wanted, and we had to work backwards. So always when you see these little inefficiency questions, always the first thing you should do is think, do I want an answer that's bigger or smaller than the answer I get if it's 100% efficient? Does that make sense?